Hello, pre-algebra students. This is Chapter 8.6, Writing Linear Equations. So far in Chapter 8, you've learned to graph linear equations, and now you're going to learn to write them. Let's get started. You can write a linear equation in slope-intercept form, y equals mx plus b, if you know the slope and the y-intercept of the equation's graph. So let's write an equation of the line with a slope of 3 and a y-intercept of -7. Remember, our basic form is y equals mx plus b, where m represents the slope and b represents the y-intercept. So all we need to do is substitute in the numbers that we've been given. Y equals m, our slope, 3x, plus our intercept, -7. Let's rewrite that just to have it be a bit more clear, that it is 3x minus 7. Now let's learn how to write an equation of a graph. So let's write the equation of the line shown here. First, we need to find the slope, m. Remember, we're starting with y equals mx plus b. Let's find the slope, m, using the labeled points 0, 3 and 4, 2. Remember, slope is equal to rise over run. So first we find the difference between the rise points, which in this case is 2 minus 3. And we place that over the run points, which is going to be 4 minus 0. This gives us a slope of -1 over 4. Okay? Now let's find our y-intercept. Where does our line cross the y-axis? It crosses it at 0.03, so b equals 3. Now let's rewrite our equation. Y equals -1/4 x plus 3. See how simple that was? Try these two practice problems on your own. Write an equation of a line with a slope of 1 and a y-intercept of 5, and then write an equation of a line that passes through the points -2, 6, and 0, -4. Now let's apply what we know about parallel and perpendicular lines. Let's write an equation of the line that is parallel to the line y equals 4x minus 8 and passes through the point 0, 2. So the slope of this given line is 4. That means the slope of the parallel line is also 4. The parallel line passes through point 0, 2, so its y-intercept is 2. All right, we know everything we need to know, right? Slope equals 4, y-intercept equals 2. So our equation will be y equals 4x plus 2. This line is parallel to our original equation, y equals 4x minus 8, because they have the same slope. Now let's write an equation of a line that's perpendicular to the line y equals -5x plus 1 and passes through the point 0, -9. Once again, we'll begin by identifying the slope. If the slope of our original line is -5, then we will find the slope of the perpendicular line by identifying the negative reciprocal of -5. So that will be 1/5. Now let's find the y-intercept, which is given to us on our points here as -9. Okay, we know everything we need to know. Let's go ahead and write this equation. Y is going to equal 1/5 x minus 9. When graphed, this line will be perpendicular to y equals -5x plus 1. Let's work through an example where we're going to write an equation from a table. This table shows a bamboo plant's growth over 8 hours. Show that the table represents a linear function, and then write an equation for the function. So let's begin by simply graphing our ordered pairs, which are 0, 6, 2, 10, 4, 14, 6, 18, and 8, 22. Let's make a scatter plot. So our first point is 0, 6. Our second point is 2, 10. Next is 4, 14, followed by 6, 18, and 8, 22. All right. The points lie on a non-vertical line, so the table here is a linear function. Okay? Now, our next job is to write an equation for this function. First, we want to find the slope using any 2 points on the line. I'm going to pick the first two, 0, 6, and 2, 10. And I'm going to find the difference between the rise and the run, which gives me 4 over 2, or 2. So our slope is 2. Next, I'm going to find the y-intercept of our line. Our line crosses the y-axis at 6, at point 0, 6 here. So my y-intercept is equal to 6. So now let's write our equation in the form y equals mx plus b. And that equation will be y equals 2x plus 6. All right. Here's a checkpoint problem for you. Which representation of a function more clearly shows whether or not the function is linear? A table of values or a graph? Explain your answer. Press pause while you work. We have one more concept to learn when you return. Let's close out Chapter 8.6 by discussing best fitting lines. In our example with the bamboo growth, the points in our scatter plot all lie exactly on a line. Often, however, there is not a single line that passes through all of the points in a data set. In those cases, we can find what is called the best fitting line. The best fitting line is a line that lies as close as possible to the data points. It may or may not pass through any of those points, but it's going to lie as close to as many of the points as possible. So let's use a graphical method to approximate the equation of a best fitting line. Here's the example. This data table shows the number of female physicians in the United States for the years 1992 through 1999. We're going to use this table to approximate the equation of the best fitting line, and then we're going to predict the number of female physicians in 2005. Okay, so we'll begin by making a scatter plot of the data pairs. And here's that scatter plot. Next, you can see that we've drawn in a line that appears to best fit the data points. There should be about the same number of points that are above the line as below the line. The line does not have to pass through any of the data points, though. Finally, we're going to write an equation of this line. To find the slope, we're going to estimate the coordinates of 2 points on the line. They've been chosen for us here as 0, 108, and 7, 177. So here we're going to solve for slope, or m, the way we've done in every prior example, by finding the difference between the rise and the run. So we have 107 minus 108, and 177, minus 108, and 7 minus 0, which gives us 69 over 7, which is approximately equal to 9.9, okay? Where does the line intersect the y-axis? We've estimated that that's at about 0, 108. So now we can write our approximate equation as y equals 9.9x plus 108. The final part of our problem was to predict the number of female physicians that will be in the United States in 2005. So let's work that out. Note that 2005 minus 1992 equals 13. So 2005 is 13 years after 1992. So all we have to do is calculate y when x equals 13, because x is our number of years. So what will it be if we have y equals 9.9 times x, which is 13 in this case, plus 108. Now we simply multiply and solve. My trusty calculator tells me that the answer to this is 236.7. So we're going to have, in 2005, approximately 236,700 female physicians in the United States. Because remember, on our plot, the number of physicians was represented in thousands. Okay, that seems complicated, but it really isn't too tough. You're basically going to make the scatter plot, do your best to draw a line that equally divides the points, and then solve for the slope, find the y-intercept, and write your equation from there. This wraps up Chapter 8.6 for us. When I see you tomorrow, we'll do more work on practice problems for writing linear equations. See you then.